some of this is review, which I just mentioned. So flexible containers enables modifying container after provisioning by enabling disabling components. I mentioned that. It allows resources to be conserved. Resource acquisition is deferred until it is needed, meaning we don't actually go out, even though even though the container blueprint may have a load balancer that's disabled, that load balancer does not get provisioned until it is enabled. So no resources get allocated on the network until they're actually enabled in the container. And so now when you looked at the blueprints under Hansel, you saw that there were conditionals put into the blueprints. Basically, the templates of commands that went out to the network device were dependent on what components were enabled or disabled. So when you look at those container blueprints in Hansel, you saw that there were conditionals out on, run this template if you're just enabling the firewall, but run this template if you're enabling this firewall as a result of this other network being enabled, that sort of thing. Right? Sometimes a different set of commands needed to go out to the network device. These were the enhancement, the changes to flexible containers over time in this fourth bullet. So enabling, disabling network and load balancers directly was in CLM3.0 or Hansel. The new item in the flexible enabling, disabling is the distributed firewalls. So in 3.1, you will be able to directly enable or disable a distributed firewall. And the distributed firewalls for 3.1 are being represented by the Cisco VSG. So whereas before you were enabling disable networks and enabling disabling load balancers directly in the container editor, now in 3.1 you will be able to enable disable the distributed firewalls directly right in the container editor. All right? Yes, follow that. So before 3.1, yes, a firewall would enable, but it only would enable indirectly when you enabled a network that was attached to it. Right now, you can directly enable, disable the distributed firewalls. And then, as far as legacy containers go, for containers created prior to 8.2, right, meaning basically containers created under CLM 2.1, which were static, right. Once they're upgraded, those existing firewalls, load balancers, and NIC segments that were in the container in CLM 2.1, they cannot be toggled. They are always enabled. And so now newer ones that you add when you reprovision can be enabled and disabled, but those existing ones can't be toggled. Those are ones that are created from CLM 2.1. All right. Getting a little bit specifically more into the distributed firewall, and some of this has to do with some information that's in the container blueprint, which I'll get a little bit more into in a minute also. But technically, under the covers, B&A made it generic, and I point out that sometimes B&A puts a capability in the system that CLM has not consumed yet. So as far as B&A is concerned, it just has a new flag called independent in its blueprint to tell you whether it can be toggled or not. For CLM 3.1, the administrators would want to ensure that they only want to set that flag when it's a distributed firewall. But that's a new flag in the system that tells the CLM whether they can directly toggle it or not. We'll use the same flag when we allow direct toggling of a perimeter firewall as well in Stryker. I mentioned this, indirect toggling occurs when a component is toggled, causing other components that are dependent on it to be toggled too, right? So when an independent firewall is disabled, the underlying firewall interfaces and ACLs will automatically be disabled. We also had to put some capabilities on so that when a firewall was enabled, that we took care of some initial ACL entries to ensure that it didn't disrupt traffic flow. So allow traffic to continue to flow when the firewall is enabled. Initial ACL entries can be defined in the blueprint if you want to have an initial set of settings on the access control list defined when they come up. Persisted path rules are reapplied when the VFW is enabled also, right? And there's some more documentation on the dynamic containers online as well. One second. It might be pinging me. Yeah, sorry. Okay, getting more specific into the VSG now. All right. One second. Okay, so Cisco VSG is supported as an additional type of a virtual firewall. The VSG Virtual Security Gateway it runs the Nexus operating system. So when you look at a VSG in the BNA screen and look at its device type, it's going to say Cisco Nexus switch. It's the same operating system that runs on the 1000V or the Nexus 5000, Nexus 7000. All right. However, it's controlled by the Cisco Virtual Network Management Center, or VNMC. Right. So if you go and look at, there's another device record that represents the VNMC. Right. It has a different device type. And if you go back over here on the left-hand side to the actual VSG, there's a new field there called Manager, meaning it's being managed by the CLM VNMC device. Okay? So when BNA actually makes changes to the VSG, it's making it to the VNMC. And for this particular device, then when BNA takes a snapshot, it takes the snapshot directly out of the VSG. So if you go and look at the VSG configurations, you're going to see every snapshot, and they're going to look like Nexus configurations. All right. Both of these VMs, the VNMC and every VSG, run as virtual machines. VNMC is represented as a manager device in BNA, and VSG is represented as a worker device. This is a new concept in BNA, manager and worker devices. You'll probably see something similar happen when we add support for Checkpoint, because checkpoints have to be managed through the Checkpoint Provider 1. The Provider 1 or the Checkpoint Management System will probably be a manager device, whereas the actual Checkpoint gateways will be worker devices. Okay? I get 2 pages or 1? All right, good. Okay, so the architecture. So the thing that's different about the Cisco VSG, and you'll hear these referred to sometimes as distributed switches, as hypervisor switches, transparent switches. But what they're doing is they're securing packets sent and received by VMs attached to the network via the Cisco Nexus 1000V, right? So the VSG is always deployed with the Cisco Nexus 1000V. And the thing that's different here is that the securing of packets is not just north-south, meaning outside of the network, like an edge firewall would do, and what we currently support with like an ASA and a firewall switch module and Juniper. It can also secure traffic east-west within the network. So VMs that are in the same network can have rules placed on them as well. All right. To perform the filtering, a port profile or port type on the 1000V, right, is configured to use a specified VSG and a specified security profile. So it's a security profile that is now getting assigned to one or more port profiles on the 1000V. Remember, the port profile is like a VLAN, it's like a network. Every time we create a bronze container, you typically are creating a port profile on the 1000V. And then when you're going to apply security policy to one or more of those port profiles, you're applying a security profile, right? So a VSG can secure port profiles across multiple 1000Vs. I'm going to represent all these bullets in this graphic down below. A single security profile can secure multiple port profiles. A security profile is modeled as an interface on a distributed firewall. That's an important thing I'll talk about here in a second. And the security profile is what contains the rules. So the rules on what TCP/IP ports, what's the source, what's the destination. All right, so based on those bullets, you can see down here in this graphic what I'm talking about here, right? We've got a couple of 1000Vs in this graphic. They are both being secured by a single VSG in this case. You have security profiles defined within this VSG that are applied to one or more port profiles. In the case of this blue one, the port profiles are on 2 different switches. Okay? And those security profiles, the security profile is what we represent in CLM as a firewall interface. So when you're in the firewall rule editor in CLM, you think about it, legacy, ASA, firewall switch module, Juniper. When you choose an interface, that typically means, right, like a port on the firewall that's securing for a particular network or a particular zone, right? Now for the distributed firewall, that interface represents a security profile. Right? So you're basically setting rules potentially across more than one VLAN. All right. On that security profile, there is a single access control list. I'll show you in the next screen, but unlike the previous like the Cisco ASAs, you had an inbound ACL and an outbound ACL. There's only one ACL on a distributed firewall, and you just have to worry about source and destination. Incidentally, the VSG can be configured either to run as a single VM running in standalone mode or as a pair running in high availability. All right. So the BNA model, VSG is represented as a guest firewall node with the VNMC acting as the firewall host. So I'm going to keep comparing this back to the previous Cisco support for the ASA. The ASA, there was a host firewall, which is like you can think of as the hardware chassis, and then the guest nodes with the virtual context that were created within them. Right? Same sort of model is being used as the VSG. The host is the VNMC, and the guests are the different VMs being spun up for each VSG. Right? A flag was added to the VFW node, the virtual firewall node, in the BNA container blueprint, right, to denote that this traffic is securing at the access layer. Right? That flag is what CLM uses to know whether it's managing a firewall or a distributed firewall. And you're going to see in CLM in 3.1, there's two tabs up there now. There's a firewall tab and there's a distributed firewall tab, right? And that flag the CLM uses down in the BNA container is what determines whether it's going to treat this device as a distributed firewall or a firewall. Now, the firewall typically is, if it's not a distributed firewall, it's going to be an edge or a perimeter firewall. You may see edge or perimeter creep up in the GUI in the Striker time frame, but basically the firewalls are your more typical routed firewalls that are securing north-south traffic going into zones or across the whole data center. The distributed firewall is a transparent firewall that's distributed across the individual ports on a hypervisor switch. All right. There's also a flag that was added to the container blueprint to, it's called independence, that triggers whether CLM is going to allow direct toggling of that firewall. And that is only supported in CLM for the virtual security gateways, for the VSG. It is not supported in CLM for any other type of firewall like the Juniper or the Cisco ASA. As I mentioned a second ago, the security profile equals a firewall interface. That is a single ACL. You're not going to see inbound and outbound in the CLM UI. It's only going to say access control list. However, if you go down and look in the BNA UI, it does refer to it as an inbound ACL. Just highlighting that so there's no confusion. But there is only one ACL that we're managing there. You cannot currently share a virtual firewall across containers, right? But you can put multiple virtual firewalls, including VSGs, in a single container. All right. Lifecycle management. The thing I want to point out here is that the guest VFW device representing the VSG is created when the VFW is enabled, or when the VSG is enabled, either at container creation if it needs to be spun up and requested at that time, or if later on it's directly toggled and enabled, right? So just like any other virtual firewall, the VSG gets created when that VFW, when that firewall representing it is enabled. And BNA currently is responsible for not only creating the VSG device in its database, which it does today, you know, when it spins up a virtual load balancer, a virtual firewall. When you do that, it creates the record in the BNA database. It does the same thing for the VSG, but it also creates the VM in vCenter. So just like in the ASA model, when BNA creates a virtual context on the physical chassis, for the VSG, it goes out to vCenter and it creates the VM. So BNA is interacting with vCenter to create those VMs representing the VSG. Likewise, when it's disabled, the reverse happens. BNA is responsible for deleting the device in the database, as well as destroying the VM in vCenter. Now, when BNA does that, it does do some capacity checks, right? It puts the VM on the ESX host with the fewest occupants. If a pair of VMs is created in VSG for HA mode, then we use some anti-affinity logic to ensure that VMs are not co-located, right? And we're still ensuring that we're choosing, when they're not co-located, hosts that have the fewest occupants. The way we do that under the covers, I'll show you this in this next part of the demo, is we use external script actions. There's several different types of actions in BNA, as you know, right? There's span actions that do snapshots and deploys to network devices. There's also an action called an external script action where we can call out to any third-party script, and that's what we're using when we call the vSphere API to basically create or destroy the VM in vCenter. Right? And the criteria, the VM deployment criteria that gets basically passed to that script, right, can be passed to the actions. They can come from the pod parameters, or they can be runtime parameters. So, for instance, if you wanted to, in the CLM runtime screen, put a parameter in there to say, all right, I want a VSG and I want it to be an HA VSG, that parameter can get passed from the CLM UI, right? Or you could just quote unquote hardcore code it in the pod parameters, so that BNA then knows and can pass it down to those external scripts to know whether it needs to spin up one or two VMs. All right. Cool. All right, so managing the distributed firewall. So this screen probably looks very familiar to you. Operationally, it's similar to managing perimeter edge firewalls, the ones we do today, ASA, firewall, switch module, Juniper SRX, except there's only one interface. Right? Except there's only one interface. And for the Cisco VSG, that interface corresponds to a security profile. So this interface, I'm sure I said interface here. I probably meant to say that there's only one access control list on it. There's no inbound and outbound, right? There's only one ACL. That's probably what I meant to say up here. The interface here is corresponding on the screenshot to a security profile. Now that is going to correspond to a security profile, which could be securing one or more port groups, port types, right? Port groups, port profiles, those are going to be listed in this port type screen, as well as the switches, all right? And then it's simply a matter of when you hit the plus here on the ACL, then you get to the rule editor that looks just like all the other rule editors, right? So the main difference here is there's only one ACL. There's not two like the other ones that we introduced in Hansel, inbound and outbound. And when you're choosing the interface, it's not representing like a physical interface. It's representing a security profile. What rules do I want to change on my profile that are applied to one or more of my VLANs is the way this works. All right? Cool. So any questions? I'm going to demonstrate some VSG management using a lab system. Because we can't get this running in the BDC yet. All right. What I'm going to do is got the right system here. I'm going to create a container on a pod. This is running in either San Jose or Austin. I'm not sure. It's a San Jose R&D system. I have a pod in here called VSG by NSW, and I'm going to create a container in there called Herndon Bronze VSG. It's a very simple container that has a single network that can have a VSG enabled or disabled within it. All right. Take a quick look at it. Again, you're just following along here. There's nothing for you to do because I'm broken out to an R&D system here. Austin Bronze VSG. Probably this one. Yeah, this is just a single network, and in this case, it's a firewall, right? Single firewall, distribution switch, and single access switch or hypervisor, right? And I'll come back in and review some of these things in a second. This right here was that external script that gets called with all the different parameters that goes out and creates the VM in vCenter. All right. But back at creating the container. So let's create a container. I'm going to call it Herndon Bronze VSG. We're going to use the by NSW pod, and we're going to choose Austin Bronze VSG, enabled HA off. Okay, by default, the VSG is not enabled here, and I'm not going to enable it yet because I want to show you direct toggling also. That's the enhanced container enhancement that we made to directly enable disable firewalls. All right, so under the distributed firewalls, here's the VFW, which is what it was called in the blueprint, and it is not enabled right now. All right. And basically just two networks, an external and a customer network. I'm just going to leave those at the defaults. And I'm not going to issue any additional parameters. We're just going to submit that. All right. And because we're not spinning up the VSG, this container creation should be relatively simple. It's probably just going to be adding a VLAN to the distribution switch and adding a VLAN to the hypervisor switch, but we'll go and check that out here in a second. Go over to BNA and take a look at the jobs. See that this is running right now. And we'll give this a second. Okay. And looks like that completed. We should have another container here. All right. Hernan Bronze VSG. So let's go take a look at that BNA job. And as I mentioned, there's really only just two actions in it. One is basically creating, and I'm kind of walking through some of these things as reminders of basic ways around the system and how to troubleshoot things. You know, switching back and forth between the jobs running in BNA and the CLM UI can be handy. But in this case, this is the template that was sent down to the distribution switch. You can see the span of the device that received it was a 6504. Basically, doing these things. And then also here's the action that was sent down to the 1000V, the creation of the port profile. All right. So the next thing to do here, and this container also can be viewed in BNA as well. Right, the actual VLAN that was created or that was acquired. Right. Okay. So the next thing I wanted to highlight, though, is the direct toggle of that VSG. So if we go back to the container, right, because there is a firewall in there, it's not enabled, right? And now we're going to edit the container. All right, next. I realized I could do this from the UI, but I saw some issues with that yesterday in this build that we're using. So I'm going to enable from the list, right? And so we're going to do a direct enable of this firewall. Right. Queued up. Back here at BNA, we should have a job running. It's rolling through the jobs right now. See the first one, it did an update on the VNMC. All right, it basically added a new tenant. Now it's in the progress right now of deploying the VSG. So it's basically spinning up the VM right now. And not only is that VM going to get spun up, but it's also going to create the record for that VSG in the BNA database and then associate the VNMC with that VSG. All right, that looks like it succeeded. Right, so now it is doing what? It's in the progress of now going back out to the VNMC and creating the firewall. If I break out to the device records here for a second, what we should see now is a new firewall. It's a Nexus. Right here. It's been named after, I basically set up the blueprint so it would be named after the container. So this was just created a second ago when we enabled that distributed firewall in the CLM UI. And you can see here that it has a manager of CLM VNMC. It's being managed by that device. And I could also take a look at the VNMCs. There's probably just the one. Right, that's the one doing the managing. Job's still running. Let's see where we are now. Still deploying out to the VNMC. So we'll give that a few more minutes. As that's running, after that's running, I'm just going to go in and create a rule on that VSG to finish off this use case. It's basically now it's out at the 1000V assigning the port profile to the security profile that was created in the VNMC. And this is all happening on real equipment. So this is real VMs. That's completed now, right? So we should have the VSG enabled back here in our container. Okay, so if we go back into the container now, we have a firewall that can be managed. BFW is what it was called. The interface corresponds to the security profile. Right? There are no rules set on it yet. Just as you are used to seeing, well, there's the single port profile it's securing, the access switch it's securing. As before, you see there's just a single ACL, no inbound, outbound. If you want to make a change to it, you got to switch over to Edit, as before, and now we can add rules. Let's add a couple. So we'll do HTTP and HTTPS. We'll just choose host addresses 16.0.0.2. Even though these are VMs potentially on the same network, I mean, I'm not going to deploy any VMs into this yet. I'm just going to set up some rules. It is securing them east-west traffic-wise. Put an HTTPS. All right, and we'll save that. And so what's happening now is that those rules, basically the security profile is being updated. And so every port profile that is has that security profile assigned to it is going to reflect those changes. So that should be represented as another job in BNA. Right, it already ran. And the changes were made through the, well, you'll see that the network span says VSG, right? But because there's a manager-worker relationship, those changes were actually pushed out through the VNMC. All right.